Okay, so 4.1, we're looking at what is probability. Probability is a numerical measure between 0 and 1 that describes the likelihood that an event will occur. So if probabilities are closer to 1, it's more likely to occur. If it's closer to 0, it's less likely to occur. Now you see P with the little a with parentheses there. That means the probability that event A occurs. So if it says P of A equals 1, the event is certain to occur. If it says P of A equals 0, then the event is certain not to occur. Again, closer to 1, it's more likely to occur. Closer to 0, it's less likely to occur. Now we have 3 ways to make these probability assignments. Intuition incorporates past experience, judgment, or opinion to estimate the likelihood of an event. So it's from past experiences, opinions. It's not really with numbers per se. Here for the second one, we have relative frequency. And what you're going to do is take the frequency of the event occurring divided by the total number in the sample. And so you actually have more along the lines of numbers that you're going to set up as a fraction for this one. Equally likely outcomes mean they're all the same to equally likely to occur. So the number of outcomes favorable to event is on top, and the total number of outcomes is on the bottom. So with relative frequency and equally likely outcomes, those are fractions that you're going to see. Intuition is going to be more of a percent of what's happened. So here for A, I have a sports announcer claims that Sheila has a 90% chance of breaking the world record in the 100-yard dash. So they're basing that off of her prior experiences. So because that's from prior experiences, that's going to be intuition. Now for B, it says Henry figures that if he guesses on a true-false question, the probability of getting it right is 0.5. So true-false is a 50-50 chance. That means it's equally likely if you're just guessing to get it correct or incorrect. So because they're telling you it's a 50-50 chance, they're equally likely outcomes. Now for C, it says the right to health lobby claims the probability of getting an erroneous medical lab report is 0.40, based on a random sample of 200 lab reports, of which 80 were erroneous. So that's your relative frequency. They're giving you your sample and then how many that fit in that sample. Okay, so I want you to try this one on your own. If anything, go through and label which ones are going to be intuition, relative frequency, equally likely outcomes, if you can't figure out what the actual probabilities are going to be for each one. But pause it and then come back with me. Okay, so you should have answers for A, B, and C here. So for A, we have a random sample of 500 students at Hudson College were surveyed, and we determined that 375 wore glasses or contact lenses. So if they're giving you the sample and then how many of that in the sample, that's relative frequency. So with our relative frequency, we always put the total on the bottom and then what we are finding on top. Now, probability can be written as a fraction or a decimal. So if I divide those two, we get 0.75. And again, that was relative frequency. Now for B, the Friends of the Library hosts a fundraising barbecue. George is on the cleanup committee. There are 4 members on this committee, and they draw lots to see who will clean the grills. Assuming that each member is equally likely to be drawn, what's the probability that George will be assigned the grill cleaning job? So it's equally likely. Everyone has the same chance at being pulled out. So when we look at this, there is a 1 in 4 chance that he will get that job, or 0.25. And again, that was equally likely because everybody has the same chance of being pulled out to get chosen for that. Now for C, Joanna photographs whales for Sea Life Adventure Films. On her next expedition, she is to film blue whales feeding. Based on her knowledge of the habits of blue whales, she is almost certain she will be successful. So if she is almost certain based on her previous knowledge, that's intuition. And if you're almost certain, it's going to be a number very close to 1. So it might be like 0.98 for our probability because she's almost certain, almost 1 for that. And again, that was intuition. Okay, so the law of large numbers is as the sample size increases and increases, the relative frequency of the outcomes is going to get closer and closer to the actual probability value. It's just like if you did an experiment where you're flipping a coin and you see how many times you choose heads and you look at that over the total number you flipped your coin. Eventually, if you keep flipping your coin, you should get 0.5 or very close to 0.5 as your actual probability over all the trials. Because if you have a coin, it's a 50-50 chance of getting a heads or a tails. A statistical experiment or observation is going to be thought of as any random activity that results in a definite outcome. So like I said, flipping a coin would be like your statistical experiment. An event is a collection of one or more outcomes of a statistical experiment or observation. A simple event is one particular outcome. Your sample space is the set of all simple events. So if we're flipping a coin, my sample space would be heads or tails. A simple event then would be getting heads or getting tails, one of them. So here we're looking at human eye color. It's controlled by a single pair of genes, one from the father, one from the mother, called a genotype. Brown eye color B is dominant over blue eye color L. Therefore, in genotype BL, we have one brown gene, one blue gene. The brown gene dominates. A person with BL genotype has brown eyes. If both parents have brown eyes and have genotype BL, what is the probability that their child will have blue eyes? What's the probability the child will have brown eyes? So we know that both parents have brown eyes and they have the genotype BL. So when we go through this, we have to match up with what we know. So if the mom has B and L, and the dad has B and L, we have to see all of our combinations. So we could have B and B, we could have B and L, we could have B and L, or L and L. Every combination together. Now, when I write this out then, if I want to find the probability of blue, there is only one of those. And you have to count the total number of options we have. There are 4 options there, so it's going to be 1 out of 4. So my probability for brown then is going to be a 3 out of 4 because there are 3 brown ones that would be left. Now you're going to try this one. It might be a little bit harder for you, but it might be helpful for A that you list out all the possible combinations. Because if you look at this problem, there are 3 questions. So you've got to think, what are all the possible outcomes that you could have for these 3 true-false questions? So for example, one possible outcome would be true, true, true. And then move on from there. So pause the video, see if you can do A, B, and C on your own. Okay, so you should have some answers for A, B, and C here. I gave you one of the first pairs. So you could have true, true, true. We could have true, true, false, true, false, true, false, true, true. We could have false, false, true, false, true, false, true, false, false, or false, false, false. So there are 8 different outcomes that could happen. Now they want the probability that all 3 items are false. There's just one of those listed. So it's going to be a 1 out of 8. Now for C, they want the probability that exactly 2 will be true. So exactly 2 to be true, there are 3 of those. So it's going to be a 3 out of 8. Now when you go through your simple events and you add up all the probabilities, the sample space must equal 1. So like I talked about heads and tails. Heads has a 0.5 chance of occurring. Tails has a 0.5 chance of occurring. When you add them together, you get 1. That's your total sample space. So every time you have to add up all the probabilities to make sure you get 1 for the total sample space. Now, complement is next. That's the A with the C there. Complement is the probability that event does not occur. So if you have P of A plus P of AC, you should get 1 because the probability of event occurring plus the probability of event not occurring should add up to 1. So if you want to find that complement, that probability of AC, you're going to take 1 minus the probability it does occur. So if we look at example 3, the probability that a college student who has not received a flu shot will get the flu is 0.45. What's the probability that a college student will not get the flu shot if they have not, what is the probability that a college student will not get the flu if the student has not had the flu shot? So if we go through this, you know that for them to get the flu is 0.45. If they are not getting the flu, it's going to be 1 minus 0.45 because you want everything else in the sample space. So if I subtract those two, we should have a 0.55. So that would be the probability that a college student will not get the flu if they have not had the flu shot. So I want you to try number 3 there. So you should have something down for number 3. A vet tells you that if you breed 2 cream-colored guinea pigs, the probability that an offspring will be pure white is 0.25. What's the probability that an offspring will not be pure white? If it's a not, that's the opposite. So you want to take 1 minus 0.25, and it would be 0.75.